Hi there. Today's episode we're going to look at our Sun, our closest star. Now the Sun is a yellow dwarf star. It's about halfway through its 10 billion year cycle, what we call a main sequence star. As stars go, it's nice and stable. It has a radius of 432,000 miles, about 695,000 kilometres, and its volume would need 1.3 million Earths to fill it. On average, the Sun is about 93 million miles, 150 million kilometres from Earth. And it spins, it rotates as it orbits the centre of the Milky Way. All natural objects in space spin to some degree or another. Now, the Sun's spin has an axial tilt of 7.25 degrees with respect to the plane of the planet's orbits. Since the Sun is not a solid body, different parts of the Sun spin at different rates. At the equator, it takes about 25 Earth days to spin once, whereas at its north and south pole, it takes about 36 Earth days. The Sun, like other stars, is a ball of gas. By mass, it's about 70% hydrogen, 27% helium, and a few other trace elements in there. And its enormous mass is held together by gravitational attraction, producing immense pressure and temperature at the core. The Sun has 6 regions: the core, the radiative zone, the convective zone. They're in the interior. And the visible surface called the photosphere, the chromosphere, and the outermost region, the corona. At its core, the temperature is about 15 million degrees Celsius, which is enough to sustain thermonuclear fusion. Specifically in the Sun's core, hydrogen atoms fuse to make helium, and we'll look at the complexity of this in another show. Energy from the core is then carried outwards by radiation. It takes about 170,000 years to get from the core to the top of the convective zone. So when you see sunlight, those photons left the core of the Sun about 170,000 years ago, because they've had to battle their way out through the compact material of the Sun. Now the temperature of the Sun drops below 2 million degrees in the convective zone, where large bubbles of hot plasma move upwards. The surface of the Sun, the bit we can see, is about 5,500 degrees Celsius, much cooler than the core, but still hot enough to make diamonds and graphite not just melt, but boil. Imagine that, boiling diamonds. And above the photosphere lies the tenuous chromosphere and the corona, which make up its thin solar atmosphere. And this is where we see features such as sunspots and solar flares. And strangely, the temperature in the Sun's atmosphere increases with altitude, reaching as high as 2 million degrees Celsius. And the source of this coronal heating has been a mystery for over 50 years. Maybe it has something to do with coronal loops that bring hot plasmas from within the Sun along magnetic lines into the corona. The electric currents in the Sun create a complex magnetic field which extend out into space beyond the planets. The volume of space controlled by this magnetic field is called the heliosphere, and it's generally considered that that is the area of space that the Sun occupies and controls. Now, it doesn't behave the same way all the time. It goes through phases of about 11 years, what we call a solar cycle, because every 11 years the Sun's geographic poles change magnetic polarity. And at the height of its activity, known as a solar maximum, is when lots of sunstorms, sunspots, solar flares, coronal mass ejections happen. And these are caused by irregularities in the magnetic field and release huge amounts of energy and particles, some which reach the Earth. Now, they don't hurt us on Earth because we have the Earth's magnetic field to protect us, but they can damage satellites and affect power grids. Well, the Sun and everything that orbits it is located in the Milky Way galaxy, as we know. More specifically, our Sun is in a spiral arm called the Orion spur that extends outwards from the Sagittarius arm. And our solar system is moving with an average velocity of about 450,000 miles, 720,000 kilometers per hour. But even at that speed, it takes us 230 million years to do one complete orbit around the Milky Way. And we think we're standing still. Well, thank you for watching. I hope you enjoyed it. And if you did, please subscribe, as we aim to get videos out released about once a week or so on various astronomical topics. And if there's something that we haven't covered that you'd like to see covered, well, message me below and I'll do my best. I'll certainly respond. So I hope you enjoyed today's show, and thank you for watching, and thank you. See you next time.